So what we're going to learn about today is graphing quadratic inequalities. Go ahead and title that at the top of your notebook. So this is a good little section to go over at the end because ultimately what we're going to do is review how to graph parabolas in all three forms. Okay, then we're just going to add in an element of shading with the inequality. So for example 1, when you're ready, we're going to graph y is greater than negative 2x squared minus 4x plus 6, okay? We have a little bit of work to do before we get to the graphing. So the first thing we need to do is recognize what form of a quadratic we're looking at, and this is standard form. And so when you're given standard form, the first thing you need to do is you need to find the axis of symmetry and the vertex. And again, remember that all of this is without a calculator. So what's that little formula that we use to find the axis of symmetry? And it's x equals opposite of b over 2a. Okay, so our b term, I'm going to kind of write this out. The a is going to be negative 2, the b is negative 4, and the c term is 6. So when we say the opposite of b, it's going to be positive 4, okay, over 2 times the a term, which is negative 2. So 4 divided by negative 4 is equal to negative 1, and we get that our axis of symmetry is negative 1. So we know the vertex lies somewhere on that line. To find the vertex, you need to plug in, and again, we're plugging it into what's called the boundary line. So when I plug this back in, I'm not using an inequality, I'm just trying to think about what the parabola y equals negative 2x squared minus 4x plus 6 looks like. So let's plug in the negative 1 in for x, and again the goal is by plugging this in we will figure out the y coordinate of the vertex, plus 6. Okay, so when we do this, again, let's always be careful that we take negative 1 squared first, which is positive 1 times negative 2. Negative 4 times negative 1 is plus 4, and then plus 6. So let's keep going. Negative 2 plus 4 is 2 plus 6, and finally we get that the y coordinate is 8. So what all of that work there did is it told us that the vertex was negative 1, 8. And we've talked about this before, that standard form is definitely not going to be the best or the quickest form for graphing. So now would be a good time to go ahead and pull out those graphs that you got in class. Okay, and you can go ahead and stick it in, glue it in, tape it in, whatever. If you don't have any graphs, just make the sketch on notebook paper. It's not a big deal. So let's go ahead and plot our vertex. And so the vertex is at negative 1, 1, 2, 3, 4, 5, 6, 7, 8. Now, what is nice about this, though, is now that we know how to graph a vertical stretch, we don't need to plug in other points, okay, anymore like we used to. So now I know, right, that with a parabola, and then come over here, if I want to graph a vertical stretch of 2, the negative part means it flips upside down. I know how it works to graph a parabola is you would go over 1, down 1 unit, over 2, down 4. Well, with a vertical stretch of 2, okay, all these vertical components are going to be multiplied by 2. So when we go to graph, we'll go move over 1 unit from the vertex and down 2, and we can reflect that point over. Okay, when we move over 2 units from the vertex, we're going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we can still, do aspects of this without having to plug in x and y coordinates anymore, but we do unfortunately still have to do that for the vertex in standard form. I already made a mistake, and it's good that I did it because you're going to do the same thing out of habit. We need to go back and we need to remember that we are graphing an inequality. And this inequality right here says that y is greater than. Well, the first thing that means is that the boundary line, this parabola, is going to be a dotted line. Okay, so let's change this parabola to look like this. Oops, not very good right there. See if I can get this a little bit better. Okay. All right, and it's going to be a dotted line, right? Okay, the next thing we need to do is we need to shade. And when we shade, we need to kind of think about this inequality as y is greater than. So if y is greater than, you are going to shade above the vertex, which would be everything around the parabola. So let me kind of do that again. If this said y is greater than, then we would shade above the vertex. If it said y is less than, we would shade below the vertex. So that's kind of how I think about this right here, is I think about shading above the vertex or below the vertex based on the inequality. And since this says y is greater than, we're going to shade above the vertex, which means not only are we shading above the vertex, but we continue to shade everything around the vertex. So that's kind of how this goes with inequalities. You either shade kind of inside the parabola or you shade outside of the parabola. And it depends if you're shading above or below the vertex. Okay, so that's how you would graph example 1. All right, example 2. Let's graph the inequality y is greater than or equal to 1/2 times x minus 1 times x minus 5, okay? So this time we recognize that we are given factored form, okay? And when you're given factored form, you need to identify the roots, the axis of symmetry, and the vertex. Okay, all of this kind of goes together. So I'm going to go ahead and start by making the graph because I'm going to use the graph to figure out some of these parts right here. You know what, I'm going to scooch this over a little bit. All right, again, if you have graphs, you can go ahead and stick those in. If not, it's not a big deal. Just graph this on graph paper. All right, so the first root right here is that x equals, well, let's go back and talk about this, right? That we've talked about before, that if your equation is in factored form, that you can set the first factor, I'm just gonna go ahead and recopy this, x minus 1, x minus 5. Remember, our roots are when we take the x minus 1 and set it equal to 0, and x minus 5 equals 0. So the roots are at 1, and the roots are at 5. So now let's come back over to our graph, and let's go ahead and plot our roots. 1 and 1, 2, 3, 4, 5. Okay, so here are the roots at 1 and at 5. The axis of symmetry is going to be 1, 2, 3. I see what's wrong with my picture. I apologize for that. Maybe you even knew it the entire time I was doing it. I just didn't graph 5 at the right spot. All right, so 1, 2, 3, 4, 5. I apologize. Okay. So our axis of symmetry is right in the middle between the two roots. So the axis of symmetry is going to be at this line x equals 3, which also means that our vertex is going to lie on the line x equals 3. So let's plug, here's our equation, right? Let's plug in x equals 3 to figure out what the vertex is. So we'll plug 3 into here. And we'll plug 3 into here and work through this arithmetic without a calculator. 1/2, 3 minus 1 is 2, 3 minus 5 is negative 2. Let's multiply all this together. This is like having 1/2 times negative 4. Y is going to equal negative 2. So this means that the vertex, okay, is on the axis of symmetry line, x equals 3, and when we plugged that back in, we got negative 2. And so let's go ahead and plot 3, negative 2 right here. Now typically when we graph, okay, I like to plot at least 5 points of accuracy so we can see that if we move over 2 units, we go up 2. I can also recall that if you move over 4 units from the vertex, you go up 16, but with our vertical shrink of 1/2, okay, we're going to multiply that 16 by 1/2. So what we can do is we can move over 4 units from the vertex and go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we can reflect that point over here, okay? So there's our parabola with 5 points of accuracy, and we are going to have a solid line this time because the inequality is greater than or equal to, okay? And again, we have the inequality greater than or equal to, which means I'm going to shade above the vertex. Well, in this case, shading above the vertex would put us on the inside of the parabola, okay? And that's where we would shade. All right, last problem. let's suppose we have a system. We can solve this system by graphing. Okay, y is less than negative x plus 1 squared plus 6. Y is greater than or equal to 2x squared minus 5. And y is greater than or equal to 1/2 x plus 2. And this is our system of inequalities where we're going to graph all the inequalities and then we're going to figure out where all the shaded overlap is. Okay, so let's go ahead and make our last graph right here. So the first thing I notice is that both of the first equation right here is in vertex form. Well, vertex form is the most convenient for graphing because we can get our vertex, right, by taking the opposite of this right here, and this right here are the vertex. So again, this x plus 1 means that it is shifted left 1, so that means the vertex is going to be -1, and the plus 6 means it's shifted up 6. So let's go ahead and graph this parabola. -1, 1, 2, 3, 4, 5, 6 right here. Okay, so 1, 2, 3, 4, 5, 6. Let's just go ahead and put in some points right here. Okay, now let's go ahead and let's graph the vertical stretch, which is just -1, which means our parabola is going to open down. But the fact that the a value is equal to 1 means that we're just going to graph a parabola, right, that's going to go over 1, down 1 unit each way, and it's going to go over 2, down 4. Okay? So it's just going to use that basic behavior of a parabola. Now this inequality right here says y is less than, so it's going to be a dashed line. And we need to think about the shading as we go. Let's not wait till the end, okay, and then try to figure out where the shading is going to be. And so if it's y is less than, we're going to shade below the vertex. So that means that we're going to shade everything inside right here is below the vertex. Okay, so just shade that really light because we still have 2 more graphs to go. This equation, okay, you could say that it's in standard form, but I can also say that it's in vertex form, okay? And the fact that there's no parenthesis just means that the vertex does not shift left or right any. So it's 0, but the -5 shifts it down 5. And so let's graph a parabola over here with a vertex at 0, -5, with a vertical stretch of 2. So recall again with your vertical stretch of 2, what a parabola normally does is go over 1, up 1, over 2, up 4. Well, we're going to multiply all those vertical distances by 2, okay? So over 1, up 2 units and reflect it over, and over 2 units, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And let's reflect that point over, okay? This is greater than or equal to, so we're going to make a solid line for the boundary line for the parabola, and we're going to think about the shading. And this time, the shading, okay, this means y is greater than or equal to. Greater than or equal to is going to be above the parabola, or above the vertex, and so it's going to shade, okay, inside the parabola. So what I'm seeing so far is that the overlap appears that it's going to be in this region right here, okay? So we've got one more inequality to go. And when you look at this, we need to be careful because we're so used to graphing parabolas, but I notice here that this inequality does not have a squared, which means it is not quadratic. In fact, this inequality is a line, okay? So we need to be careful that we recognize linear equations, and that means that the slope is 1/2 and the y-intercept is equal to 2. Okay, so let's go ahead and graph this line right here. Here's my y-intercept of 2, and I'm going to move the slope up 1 over 2, up 1 over 2, and we can also reverse it and go down 1 over 2. And so this is going to be a solid line for the boundary line. Now, when we graph this inequality, which is going to be greater than or equal to, I'm shading everything above the line. And so what we're going to end up seeing is that the overlap, okay, of all 3 of these regions, maybe I should just probably do this in black, the overlap is going to be this this little region right here. Okay, so that's the idea of how to graph quadratic inequalities. Really, overall, it should pretty much feel like review of graphing parabolas. We just need to think about which direction that we shade. Okay, that's it for now.